So in the last while with stats, we have gone to what's called grouped data. And grouped data is when data isn't in a list, it's in a table form. And so when it's in a table form, you lose some of the detail, but you get more of a summary. And so today we're going to go over more stuff on group data, and we're going to also look at some graphs that we get if we start to take data that's in a table and we represent it as a graph. And so these graphs that we're going to talk about are the histogram, the frequency polygon, and ogives. And we're going to have to add some more tables or add some more columns to our tables to help us. So to start today, here is an example, and it says at a particular primary school in Pietermaritzburg, it was found that 90 of their foundation learners, phase learners, were accompanied to school by someone. So basically, foundation phase learners walk to school with someone, which seems like a good idea to keep them safe. The ages of the person accompanying the child were recorded as shown in the table. So these are the people who were accompanying the children who were in foundation phase. Now, you'll notice here the interval is 0 to 10, 10 to 20, 20 to 30, and so on. This is the number of people who were accompanying children. Now, what we say about these intervals is that this age is a continuous data variable. So you can have anybody from 0 up to and including 10 in that interval. The end points are 0 to 10. Okay, this data, we don't know if there's a 9-year-old or a 6-year-old or a 12-year-old. We just know it's someone between 10 and 20. Okay, given that, I want you to tell me the modal interval for this grouped data set. Tell me in the chat, what is the modal interval for this grouped data set? What does the modal interval mean? So the one that has the most is 30. It's got the highest frequency count. And so the modal interval must be between 10 and 20, which makes sense. It's probably other school learners who are walking them to school. Okay, this is the group mode or the modal interval. Now, I'm going to jump to C, which is the median age. So now this is a different measure of central tendency. And I'd love someone who was here last week to maybe jump on and tell me where do you start with this? If I want to find the median interval, what would your first step be? Would you add anything to the table? Would you do any calculation? What would you do? You can pop your hand up or you can put it in the chat. What would your first step be if you were trying to find the median age? Okay, my suggestion is to add a column for cumulative frequency. So I'm adding a column for cumulative frequency because it keeps track of how many people up to a certain age have been included. So if I do the cumulative frequency column here, I'm going to have 12, 42, 60, 72, 81, 87, 90. And so in total, I have 90 people who are involved in this data set. That makes sense because they told me earlier on it's 90. Okay, now, next step. Now that I've got this column for cumulative frequency, what do I need to do next to try and figure out what the median age is? I know you want to help us out there, Callan. What would you do? Or Mrs. Siwa, what would you do? What would you... I need to find the median age. The median is the one in the middle. But normally you have to make sure the data is from smallest to biggest. Almost. Do you remember for the median last week, we would find the position of Q2, and then we would find the median. Now we have to find the median interval, but we still have to find the position of the median. So I'm going to use the formula a half equals n plus 1. I want you guys to tell me, using this calculation from last week, what is the position of the median, and then we will figure out the median interval. So in the chat, I'm looking at the chat now to see what students can help me out. So I'm going to say a half times 90 plus 1, and Cullen has indeed helped me out, 45.5 position. So basically, I want to go, if I go from the smallest to the biggest, I want to get to the interval that contains the 45th or the 46th item in this list. Now, the reason that the cumulative frequency column is so helpful is at this point, there's 12 people who have been counted. If I go up to here, there are 42 people who are under the age of 20 or equal to 20 who are involved here. Have I reached the median interval yet? I've got to the end here. I've counted 42 people. Have I got to the median interval? Yes or no in the chat. I have not, because the position is 45.5 and I've only got to 42. So what interval is going to contain the 45th or the 46th item? So Bukle, what you're looking for is you're looking for the position 45.5 or 46. If you go to you've got 12 up to here, you've got 42 up to here. Up to here, you've counted 60 people. So you've counted far enough. When you get up to 60 people, you've gone far enough. So the interval has to be between 20 and 30. Or let me just put here. I'll come to you in a moment, Bukle. Just keep your hand up there. So let's go to Bukle. Bukle, how can I help you?
So it's not like a cumulative position where, because you already have 12 positions, it's not like that. It's just 12 and now we're moving on to the next one.
Yeah. Well, okay, here's the thing. If you were counting the frequencies, right? 12 plus 30 is 42. But that's the whole point of the cumulative frequency column. It's counting it for you. So even if you had just done the frequency column, Bukle, when you get to 42, do you agree that you're not far enough yet?
Yes, sir.
So then if you go into the next one, now you've gone all the way to 60, now you've gone too far, which means the median interval has to be in that area. Does that make sense?
Yeah, I understand now.
Thank you for your question. Okay, now, last one. We need what's called the estimated mean. Now, you can do this with your calculator, and I've shown you a video that does that, but we are going to do it manually now. Now, for the estimated mean, you are going to divide by the number of items. So the number of items is going to be 90. But what do we do for the actual data items? Since we don't have a list, we know there's 12 people between 0 and 10. But what number do we use to stand for those people? Who can tell me? Maybe you can raise your hand or put it in the chat. So like, I know there are 12 people who are between the ages of 0 and 10. But now, if I want to estimate the mean, I need a number from between 0 and 10. What should I use? Helen, you have smashed it. It's the midpoint, yes. And you know what I'm going to do? Is I'm even going to add an extra column just so I don't get confused for the midpoint. All right? And what I want to say to you is that where the midpoint is depends on the values here. So this is a continuous variable. So between 0 and 10, you add what's the first value? It's 0. 10, so this would be 5. Then this one is going to be 15, 25, 35, 45, 55, 65. So these are the midpoints of the interval. Now, if I want to get an estimated mean, all I'm going to do is go 12, because there's 12 items times 5. Plus, I am going to go 30 times by 15. And I'm going to carry on doing that until I get through my whole data set. I want everyone to take out their calculator now and to finish this calculation for me. And then I want you to give me the estimated mean. So I want everyone to play along at home. It's like it's a game show. You get to play along too. Put these values in your calculator. I'll help you to see what's going on. You go 18 times 25 plus 12 times 35. Maybe I should tick them off as I go. Plus 9 times 45 plus 6 times 55 plus 3 times, sorry, 6 times, yeah, and that's 65. So these are all the items I needed to add up, and then I'm dividing by 90, and I'll get my estimated mean. If I used my calculator, I would just be using this column over here and this column over here. That's the other way that you could do it. All right, I want answers in the chat from my students. I'm waiting for the people to help me. I'm going to do it also. 12 times 5 plus 30 times 15, 18 times 25 plus 12 times 35 plus 9 times 45 plus 6 times 55 plus 3 times 65. So I get the number 2,310, but that has to then be divided by 90. Did you get the same? What are you getting for your final answer? I get 25.67. So just to show you the 3 measures of central tendency, this was the modal, that was the modal interval. This was the estimated mean, and this was the median interval. But the median interval had to do a little calculation first. Okay, time for a bit of feedback from the class. How, on a score out of 10, how comfortable do you feel filling out the extra column of cumulative frequency, midpoint, and working out these 3 measures? Tell me out of 10 how comfortable you feel doing that. Let me know in the chat how comfortable you feel doing that. Now remember, you can also look over this in your own time to help you, but today was just getting you started. Thank you, Oratile and Tandiwe, Bukle, Tamia, Callan, Ganlin. Keep those answers coming through. Okay, now I promised you some graphs of grouped data. So the very first graph that you're going to learn about is called a histogram. And all a histogram is you have a continuous variable over here, like age, and I'm going to find the frequency count of a particular interval. So from 0 to 10, I've got 12. So I find 12 over here, and in that interval, I'm just going to color that in. So that is the very first thing there. Then I go to my second interval. So I'm going to pretend that I've done that. From 10 to 20, I should have 30. So I'm going to go all the way up to there. and I'm going to color in my bar. A histogram is a lot like a bar chart, except it has a continuous variable along the bottom, so it has no gaps. Okay, so that's that one. Then from 20 to 30, I goes, so that's the age. From 20 to 30, I have 18. So where's that going to go up to? It's just going to go up to there. I want you to take out your ruler, and I want you to finish this histogram for me. So all that you need to do, you don't have to take super long. You're going to have a vertical axis, and you are going to have a horizontal axis. And you are going to mark off it in tens, because that is the way that the data set was done here. And all you are going to do is you are going to compare the intervals to the frequency. A histogram has frequency on the thing over here, and it has age intervals. Well, it has intervals over here. So I want you to complete this histogram by yourself. I've done the first three. I'm going to get rid of these two columns for now, just to take away some of the confusion. And a histogram is just a graph of grouped data. I've done the first three intervals for you. Let's get rid of all that, and we'll say, what do I have going on here? Here I have 10, 20, 30, 40. So you're doing this in your book. You've got 0, 10, 20, 30, 40, 50, 60, 70, and I'll say 10. And I want you to look at these and see what your histogram looks like. And a histogram is just a example of a grouped data graph. The data is grouped in a table, and now you're showing the story of that data in a graph. And some important things are that the column, the headings over here, this should be frequency. So it's just a simple count, and over here it will be intervals. And in this case, the intervals are about age. When you are done with your histogram, will you just say done in the chat? I'll redo this over there on the other one in a moment. So let's see over here. So we have that is going to be 12. Then it goes up to 30. Then it goes up to 18. From 30 to 40 is 12. So it's just above 10 there, basically. 40 to 50 is 9, so it's just below here. And then 50 to 60 is 6. And then 60 to 70 is 3. So this is what we call a histogram, and it's not super difficult, but it's important that you know how to read information off it. And so what I noticed, these are the same histogram, but because the scale that I used for this one was a little bit more compressed. Can you see it almost looks different? And it's the same graph, and the only reason is the scale is different. And I actually prefer this one because I feel the scale is easier to read. All right. Give me a score out of 10 for how well you feel like you understand what a histogram is. Give me a score out of 10 for how well you think you understand what a histogram is. All right, now there's another graph that we talk about with grouped data, and that is called a frequency polygon. And a frequency polygon is like a cousin of the histogram to some degree. But what's important about the frequency polygon is it uses the midpoints of the interval. So remember before I had these midpoints and I took them away. So I'm going to put them back in a second. The midpoint here was 5, then it was 15, 25, 35, 45, 55, and 65. That's the midpoints of these intervals. If you imagine that on my drawing, they would be in the middle of this. Now, the good news is a frequency polygon is super simple. I have to add an interval on the one side, and I have to add another interval on the other side. Now, that's a bit weird, but I think most of you can see that the interval would go from -10 to 0. And then over here, what would the interval be that comes after 60 to 70? I'll make this a bit thicker. So this one over here, the interval below this would just be -10 to 0. What would be above it? It would just be 70 to 80. Yeah. Okay, so I've added these two intervals on the end of my histogram, and you may say, like, why have I done that? But I'll show you in a moment. But basically, for now, you're just trusting me. Okay, now, how do you draw a frequency polygon? All you do is you go to the middle of your histogram and you make a dot above the midpoint. So all of these over here, above the midpoint, above 45, above 55, you will have dots. In the interval that is on the ground, you simply put a dot in the middle of that interval, and you put a dot in the middle of that interval. Now, a polygon is a shape that has straight edges. So what you are going to do is you are going to connect up these midpoints with straight lines. These are not curved lines. These are straight lines. Now, it looks a bit curved there, but these are all straight lines as I go. And this is called a frequency polygon. And a frequency polygon is just superimposed over a histogram. So you literally just take the midpoints of the histogram, and then you add two intervals on each side, and you connect them up. That's it. Okay, so that is called a frequency polygon. So the histogram and a frequency polygon are pretty much the same thing. We're going to practice this after the break. Before we do that, I want us to just do some multiple choice questions quickly. So about histograms, and then we'll take a break. So if I look at this histogram, it says, Jim measured the temperature at 2 p.m. at the same spot in his garden and recorded the results to the nearest degree for each day in the year. The results are shown in the following histogram. Then it says, on approximately how many days was the 2 p.m. temperature above 70 degrees Fahrenheit? So on approximately how many days was the 2 p.m. temperature above 70 degrees Fahrenheit? Now I want you to read the scales. Look at the scale, number of days on the left and temperature on the right. How many days would have had a temperature above 70 degrees Fahrenheit? Now, If we have to read this off, I think 2 is 5. That is about 64. This looks like 131 or 132. That looks like, if that's 60, 65, 70, 75-ish. This looks like it's about 50. This looks like it's about 25. And this looks like it's about 5, 10. It's about 12 or 14, maybe it's 13. Let's think about what this means. On 64 of the days, the temperature was between 30 and 40 degrees. On 131 days, it was between 40 and 50 degrees. In between 50 and 60, the temperature on 75 days, it was between 50 and 60 degrees. I want to know on how many days was the temperature above 70 degrees Fahrenheit. And you have to choose from these four options below. Which one do you think it's going to be? Which blocks or which intervals are above 70 degrees? I think that this interval is above 70 degrees, but so is this one over here. So how many days do we have in those two intervals? How many days do we have in those two intervals? Well, there's about 25 here, and there's about 13 there, which is about 38 or 39. And so I would say in total, there's approximately 39 days where the temperature is above 70 degrees. So there's the 25 that are between 70 and 80, and there's 13 that are between 80 and 90. Give me a thumbs up if you followed that logic and that thinking. Give me a thumbs down if you're like, what are you talking about? Okay, fantastic. All right, it's break time. And you know what happens on break time? We all stand up. So join me, everyone, in standing up for a second to get some oxygen and blood flow back into your body. We need this so that our brains keep on performing. Okay, let's take 3 deep breaths. That's 1. That's 2. That's 3. And give your arms a shake. Give that arm a shake. Give your legs a shake. And then we're going to do 15 jumping jacks. Make sure the space around you is clear. And we'll go in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. I know my body feels like it's had a bit of a break. Before we move on, please give me your favorite emoticon in the chat. I'm going to choose the heart because my heart is pumping from jumping up and down. I want you to hit the emoticon that you feel like right now. Okay. Hang in there, Oratilia. We've got your back. We will help you. All right, now, some quick questions here. If we look at this histogram, what is the modal interval? So as we look at this question here, what is the modal interval? So we're back. This is grouped data table. We've got a table here. What is the modal interval? What range of temperatures to, oh, yeah, I want to see what you guys. What do we think? Bouchle has pulled the trigger. Callan has participated. Who else has a interval that they can see? Well, I see this big one here. So for me, the modal interval will be between 40 and 50. This one over here, that's the modal interval. Okay, but you know what's coming next? What is going to be the median interval? Now, I know that there was a little bit of extra work we had to do to find the position of the median to help me here. Do you remember that? How do we find the position? How do we find the median interval here? Well, we need to do this calculation of half times n plus 1. But what is the n going to be? I want you to go back to this question. What do you think the n is going to be based on this question? So it says for each day in the year. Now, if this is adding up to basically 1 for each day of the year, what does n have to be? 365. Yes. So find me the position of the median, not the actual median interval yet. We're still going to get to that. What is the position of the median? What is the position of the median? So it is position 183. Okay, now, as we go back to the data table, how do we know which interval 183 falls into? I want to give you a chance. Which interval do you think the median falls into? If you look at these totals, where do you think the median will fall? Into which interval? You can kind of imagine there being like a frequency column. So like frequency, and there'll be like a 64, a 131, a 75, a 50, a 25, a 13. What interval? Well, for me, I don't even have to do the cumulative frequency. I could do it, but I can kind of see, like, if I gave 64 over here and I add 131, so 64, I clearly need to go further than 64, because remember, I'm trying to get to 183's position. But if I add 131, I get to 195. So now I've gone too far, which means the median must be in that interval. And so the median interval will be between 40 and 50 as well. Okay, oh, one last thing. If I wanted to turn this histogram into a frequency polygon, what would I need to do? If I wanted to turn this histogram into a frequency polygon, what would I need to do? You can pop your hand up if it's quicker. I just want to know the key steps to have a frequency polygon. Okay, put dots on the midpoints. Yeah, so find the midpoints for each of these. And it should be in line with this. We add an extra interval and we put a midpoint for those ones as well. And then all we're going to do is we are going to connect those things with straight lines, like our ruler. And this is called a frequency polygon. And a frequency polygon must close. It always goes through the midpoints of the interval, and it must be closed because it's a polygon. And that's why it needs to go back down to the ground. Okay, everyone, we are doing well. Let us continue on our journey. Let's do another one like that. So, first question. Here is a histogram. It's recorded for all the days in a year. It says, on approximately how many days was the rainfall less than 10 millimeters? We have rainfall on the horizontal. We have frequency or number of days on the vertical. How many days was the rainfall less than 10 millimeters? And you can choose the option A, B, C, or D. Pop your answer in the chat. It's quite helpful to write the numbers on top here. So let's see, I'm going up in fives. 120, 135. Here, I'm going to go with like 81 because it looks a bit like 81 to me. It's not perfect because the scale isn't perfect, but that to me looks like a 70. That to me looks like a 40. Oh, it's almost up to 50. So let's say 48. This looks like a 25. This looks like an 8. No, not even, maybe like a 7, 6 or 7. I'm going to go with 7. Okay, so those are, if I had a frequency column, those things would be 135, 81, 70, 48, 25, 7. And the intervals would be 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. So how many days was the rainfall less? Now, the tricky bit was they were saying not greater than 10, it is less than 10. So I would like you, now that I've given you that hint, which answer do you think is correct? Oratile, Tandiwe, Buchle, I have good news. All you need to do is add up 135 plus 81, and then is there anything close by? Answer is D. Okay, now we are going to estimate the mean. So we've done this thing over here, but we're now going to estimate the mean. Actually, you know what? We're not going to. Well, you can do that. The way you would do it, I'll just tell you. If you wanted to estimate the mean, all you would do is say that how many total values are there? There's 365. Then you would say, what is the midpoint on each interval here? The midpoint here would be 2.5, 5.5, 12.5, 17.5, 22.5, 27.5. And all you would do is you would say, you would basically just use this column. So you would say 135 times 2.5. And then you would basically get all these things like we did before. You'd go 135 times 2.5 plus 81 times 5.5 plus, and you would get all those things. And then you would divide them up and you would get an estimated mean. You could also use your calculator by using these two columns. Give me a thumbs up if you could follow what I was doing with that question. Give me a thumbs down if you didn't follow. I want to get a feel for how the room is doing. Be honest, or you can give a score out of 10 if you feel like that's a better way to do it. Okay, well then let's keep swimming. So I want to ask you some We've done frequency polygons. We'll come back to that when we can. Let's do, let's have a look here. Let's do some multiple choice questions. So it says, the table shows the weights of tomatoes in a competition. Dave wants to draw a frequency polygon. Okay. For the second row, what value should the plot on the y-axis, should be the plot on the y-axis? Which of the four options do you think is going to work for my frequency polygon? For the second row, what should the plot be? So if we were drawing this, remember that we always have the middle. So between 0 and 40 is going to be 20. So the point is just going to be, let's have a look. So if we had this interval 0 to 40, so let's actually do that. So if that was a 40, and then that was 80, that was 120, that was 160. And if I need to add an extra category on this side, and I need to add an extra category on this side. So we're going to go 200, and here we can go minus 40. And if I was plotting this, it would be, what would the frequency be? Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I had a histogram, the histogram between 0 and 40 would go up to 3. Between 40 and 80, it would go up to 9. Between 80 and 120, it would go up to 3. Between 120 and 160, it would go up to 5. And then these bits over here. So if I imagine the points that I'm going to get for my frequency polygon, they are going to look like that. So let's see. For the second row, what value should the plot on the y-axis be? Okay, they are talking about this row over here. For me, the y-axis is here. And so in their table, the second row is this one. What is the y value of the plot? Well, it's in line with 60 here, but the y value is actually 9. And the answer is B. Give me a thumbs up if you understood that. Give me a thumbs down if you didn't understand where the 9 came from. Because that was quite a tricky question, but you kind of saw how I made my histogram and then could have sort of worked out the question. Okay, let's do another one. Let's do this one. The table shows the weights of tomatoes. Dave wants to draw a frequency polygon of the data. For the second row, what value should the plot be on the x-axis? Would you get A, B, C, or D? Remember, they're talking about the x-axis here. So we can use the same drawing as before, except we're focusing on the x. So let me go and grab the drawing I had before. Sorry, everyone, if I'm making you dizzy. I just want to grab this so that we have it nearby. Oh, what happened there? It'll come back now, I promise. Oh my gosh, I'm making it angry. Maybe I can put it on the side here. Will it let me? Oh, it's okay. Well, I'll put it down here. If we look at the second row, and I look at the point on the second row, if I want the x coordinate of that point, what is it going to be? It looks to me like the x coordinate for that thing over here is going to be 60. And so the answer here is going to be C. Because remember, like a frequency polygon, even though it's made from a bar graph, it's made up of points. So like if you imagine that very first point, 1, 2, 3, it has what are the coordinates? It has the coordinate 23, and then the next coordinate is 69, and then the next coordinate would be 103. These are the points that I'm connecting up to make my frequency polygon. Give me a score out of 10 for how well you understand frequency polygons. I just want to get a feel for if I'm helping or if I'm hindering. Give me a score out of 10 for how you're feeling about frequency polygons. Okay. All right, last question for today. Which of the following diagrams requires you to join midpoints together with straight lines to draw it? Is it A, B, C, or D? Which option do you think is going to be correct? Well, it's not the histogram, because the histogram is kind of like a bar graph that has no gaps and has a continuous variable. It's not the cumulative frequency diagram, or what we call the ogive. That's coming in the next lesson. It's not a frequency diagram. It's called a frequency polygon. And a frequency polygon has these straight things between each of the points that we are drawing. And so this is just another grouped data graph that we learn about. Okay, so just to summarize today, what did we look at? We looked at grouped data tables. We looked at the importance of sometimes adding a midpoint column to a data table, and also sometimes adding a cumulative frequency or column. We spoke about drawing histograms. We spoke about drawing frequency polygons. We spoke about finding the modal interval, the median interval, and the estimated mean, which are kind of like measures of where is the middle of the data in a data set. In the next lesson, we'll do ogives and interpretation questions for the topic. All right, everyone, that's today's lesson.